Welcome to our final section. In this section, the first thing we're going to do is just take a little tour to see some other examples of models besides linear models. Then in the final video, we're going to summarize what we've done in the course and talk very briefly about the project. But let's start just by seeing some examples of other models. So we've already seen a little bit with the World of Warcraft experience points. So in this case, we'll just use y and x's. And if x is your current level and y is the XP you need to get to the next level, then for levels 1 to 11, according to a wiki web page I found, the equation for the XP you need to get to the next level is y equals negative 0.4x cubed plus 40.4x squared plus 396x. I don't know why. This is called a cubic function. It's an example of something called a polynomial. Polynomial functions are where you take some variable and you raise it to various positive whole number powers, multiply by numbers, and add them all together. In this case, this is a third degree polynomial. The highest exponent is a 3, and that's called cubic because, 3 dimensions to a cube. You can see the graph to the right for levels between 1 and 11. Right? You can see that there's some curvature. But let's just take another look and zoom out and see what this function would look like for other values if we extended this function to other values of x. So on the left side, you can see what this function looks like if we graph it for x ranging from roughly negative 15 to out to about 116. Right? We've got kind of this smooth curving hump here. It's actually kind of pretty. The portion for World of Warcraft is between 1 and 11, so it's this little piece right here that we were seeing. If we zoom out even more, we get the picture to the right, where x here is running from negative 600 to 600. And if you take a look at this portion here with this nice looking kind of bump here, that's going to be buried in this region. And because the scale has become so large, we can't even see it in this picture. Notice also on the y-axis, notice the numbers that are involved. They're in scientific notation. 1 times 10 to the 8th, 5 times 10 to the 7th, negative 5 times 10 to the 7th. So that's telling you how big those values are. All right, let's look at a few more examples. Exponential functions. These come up quite often. These functions occur when you have a constant percentage rate of change, not a constant rate of change. Just as an example, if you were to take 100 and add 5% of the value, you get from 100 to 105, but then you add 5% of 105. Then you add 5% of that, and so on. So it's not the same as linear functions, right? We're going to have, it's different. And they get a new name, exponential functions. So here's an example. This is exponential decay. Radiation is something measured in something called sieverts. And let's say we're running the Death Star from Star Wars, right? And the core of the Death Star emits radiation right at the core at a level of 100 sieverts. But as you walk away from the core, imagine it's in a central location, as you get further and further away from the core, the radiation level falls off at 25% per meter. So because you've got that constant percentage change, we have an exponential function here. The way the exponential function is written is what do you regularly multiply the initial value by? Well, the initial value is 100, and because we lose 25%, 75% remains, so we multiply it by 75% for every meter away from the core that we are. So if we're x meters away, we multiply it by 0.75 x times, and repeated multiplication is exponential, gives us exponents, so that's codified as 100 times 0.75 to the x. You can see the graph to the right. You can see how it initially falls off very quickly and then slows down and flattens out. Just a couple more examples. Let's look at periodic functions. Periodic functions have some shape in the graph that occurs over and over again. So this picture, you see this shape that occurs, and that shape, the entirety of the shape is called a cycle, and then those shapes occur cyclically. A good example of a periodic function are those readouts on EKG machines for your heartbeats. And one last example, one of my favorites, logistic functions. You can see this is something that grows very, very quickly, but then eventually saturates and flattens out. This is the kind of thing you see when something grows grows exponentially within a fixed population. For example, a disease. If we let this COVID virus run rampant without any mitigation, then it would start by growing exponentially, but once almost all of the population has been infected, there's not much population left to be infected, so the growth rate will slow down. Not necessarily a good thing because it means almost the entire population's been infected. Another example is the spread of a rumor or the spread of misinformation. Information, or as one writer calls it, bullshit, spreads very, very quickly, and then eventually it'll slow down once enough people have heard the rumor or heard the bullshit. All right. I'm not going to ask you to do anything with these models. I just wanted to expose you to them because we put all of our energy into linear functions, and I wanted you to see that there's a much wider world out there, and these functions can be really cool. All right. In the final video, we're going to do a summary of the content that we've covered in this course, and then we're going to proceed to the project.